Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss about the average velocity and instantaneous velocity. So it can be solved by using the two techniques, by using the slope method or by using the derivative method. So here, average velocity is given by the change in the position over time elapsed. And instant velocity is the slope of a tangent line or the limiting value of this velocity, average velocity. Whereas in the derivative, you have to calculate the given function f s of t plus h minus s of t over h. So this is the average velocity. If you take the h approaches to 0, this is the instantaneous velocity. Now we will solve the one problem using both the methods so that you can get the clear idea about the topic. Now this is the function here. Question is given the displacement of the particle moving in a straight line is given by. So this is the function is given and find the average velocity at the time period 6, 8 and 8, 10. So there are two intervals are given. You have to find it the value from these two intervals. So I will solve using the first slope. I using slope using using slope method using slope method. So first of all we have to do it here. The given function, what is the given function is given here? The displacement s of t, which is given by t square minus 60 plus 3. Now I have to calculate the average velocity. As we know, the slope is nothing but y2 minus y1 over x2 minus x1. So how will you calculate y1 and y2? By using this function. So I just substitute the x2 value, you will get y2. When I substitute x1 value, you will get y1. So this is what we will do it to calculate the point. Now this is the average velocity first. Average velocity. Average velocity given by at the point. So at the point, this is the 2 points are given. So I will take the first point 6, 8. So since it is these values are x1 and x2, this is the x position. Now what is the average velocity here? So average velocity is given by s of 8 minus s of 6 over 8 minus 6. So this one you can calculate using calculator. So using calculator we will do it this one. So here we have a calculator. So I will open this calculator here. So I will fix the function. What is the function here? This is alpha x square minus 6 alpha x plus 3. After that, cal c. Give the value of 8. So this is 8. I press 8. So equal. So it is 19. So I got it. This value is equal 19. Minus, same thing. The function is already fixed. No need to fix it again. So just press cal c button. Give the value x equals 6. So therefore it is 3 over, this is 2. So it is 16 over 2, which is equal 8. So this is my average velocity between the interval 6, 8. So this is the units you have, meter per second. Now similarly, I will take the second thing. So what is the second one? 8, 10. So this is the average velocity, the same rule, nothing new. So it is s of 10 minus s of 8 over, this is 8 minus 10 minus 8. This is what we have, y2 minus y1 over x2 minus x1. Now the same thing, the function is fixed in the calc already. No need to fix the value, just put it 10. Calc 10, it is equal 43 for 10. And here next, Calc, give the value 8. So you will get 19 over 2. So if you simplify, you will get the answer is 12, 24 over 2, which is equal 12 meter per second. So this is my average velocity of between the intervals 8 comma 10. So let us calculate the same problem by using the derivative method. So what is the derivative method? The rule is this one. So I will take this part. So using derivative method, using derivative method. So first of all, we will calculate the numerator part first. For this one, I will calculate this part. Since the s of t is given in the question, so I will calculate s t plus h minus s of t, which is equal. So this is t plus h whole square minus 6 t plus h plus 3. So this is the first term is over. This is the first term. This is the first term. Now minus the same thing. What is that? T square minus 6t plus 3. So this is the second part. Now I have to expand this one. So what is the expansion for this one? So we will have here t square plus 2ht a plus b whole square root. So this one is rule here, minus, multiply the 6 inside, minus 60 minus 6h plus 3, and multiply the minus, you will get here. So it becomes minus t square plus 60 minus 3. So what are the term get cancelled? So 3 with the 3 cancel, then 60 minus 60, t square minus and plus get cancelled. So what is the remaining terms you have here? So it is 2ht plus h square minus 60. So if I take the h as a common factor, so 2t plus h minus 6. So this is what you will get it. Now I just substitute in equation number 1. So this is my equation number 1. Now if I substitute in 1, so average velocity is given by, so average velocity is given by, so average velocity is equal h 2t plus h minus 6 over h. So h with the h cancel, and here, so what is the remaining part? 2h plus 2t plus h minus 6. So this is over h is there. So this over h and the common factor h, it get cancelled, and the remaining part is 2t plus h minus 6. Now how will you calculate the points? So first point, take the first point. I will take the first point. What is that one? 6 comma 8. In this one, the starting point is nothing but my t. So this is t is nothing but the starting value. And what about the h? H is nothing but the difference between these two. So which is 2. So how will you get 2? This is actually 8 minus 6. So which is equal to. Now if I substitute in the average velocity, the average velocity implies, so it is 2 times of 6. So it is 2 times of 6 plus 2 minus 6. So answer will be 12, 14 minus 8, which is equal 8 meter per second. So 8 meter per second. So you will get a same answer what we find it in using the slope. There is no change in the answer. Now the second point, I will take the second point. What is the second point you have? So 8 comma 10. So I will choose this one as 8 and h, which is equals 2. So what is this one? 8 minus 10 minus 8, which is equal to. So this is the h is the difference. Now here velocity, average velocity is equal 2 times of t value is 8 here, plus h value is 2 minus 6. So it is 16 plus 2, 18. 18 minus 6, which is equal 12. 12 meter per second. So this is the average velocity between the point, between the interval 8 comma 10. So if you see this one, so answer will be the same at the point you have, it is 8. Similarly, by using the derivative, we will get the same result. And here the interval 8 comma 10, you will get the average velocity is 12. So by using this derivative formula, you will get a same answer. Now let us go with this one, the instant velocity of the particle. So here what you will do, here I will do it this part as when we calculate the instant velocity v of t, I have to go with the slope of the tangent line. So this is the rule is slope of the tangent line. So you have to reach near to the 10. So you will take any value near to the 10 value. So here I want to calculate when t equal 10. So what is the average velocity? I will take, this is a 10. So you have 10 here. So if I move it from the right side, you will have what? So you can give the number as 9.99. So what should be the value? So this is the instant velocity, the slope. So it is the slope of the tangent line or the limiting of the average velocity. So we will calculate the approximate value 9.99 we will take. So here the velocity is given by, I will calculate what happened if it is 99 and comma 10. So what happened? So this is the same thing, s of 10 minus s of 9.99 over 10 minus 9.99. So therefore you will find it the value is equal. Similarly, I have the same function, no need to fix, just press 10 here. You will get 43 for 10 minus the function you will have here cal c 9.99. You can increase, you can give 9.9 or 9.99 or you can give 9.999. So we have to give the limiting. This is the instant velocity is the limiting. So this one you will get it as 42.8601 over, and here 0.01. If I divide, you will get the value is equal 13.99. So which is approximate. If you increase the zeros here, 999 or 49, you will get approximate value. It will reach to 14. So it will reach to 14. So this is the instant velocity. Now let us go with the average, the instant velocity using the technique, the derivative techniques. So what happened? So here using the derivative technique, we will have the formula, the limiting value. So I just copy the same thing here. Yeah, so this one is the same. Just you have to take the limiting function. Limiting, yeah. So already we have calculated this part in the numerator. So if you see this one, this is already we have calculated. So this part is already calculated in the above average velocity, which is going to be your this one. This is the already we have calculated. So just I substitute the value here. So what happened? Average velocity is given by limit h approaches to 0, and then you have 2t plus h minus 6. Now when I substitute the h equals 0, so this becomes 0. Now what are the remaining things you have? Here 2t minus 6, but I have to substitute the value of t. That one it is mentioned in the question. So what is the value of t? So t value is 10. So I just substitute 10 minus 6. So this value, t value will be given in the question. So final answer will be 20 minus 6, which is equal 14 meter per second. So this is a 14. This is 14 meter per second. So you will get a same answer using the derivative technique as well. So this is the one problem we have taken in which we solve using the slope method and using the derivative method. So answer going to be the same. If the question is mentioned by using slope method, that is 2.1, you have to solve by using this method. When if it is asking using derivative method, you have to solve by using 2.7 by using this method. If it is nothing is asking, just the question is given, it is your choice to choose which method you want to solve. And we will have one more question here. One more question I have solved already. For your reference, I just explained for you. So here we will have another function. This is s of t is given. So there is a 4 intervals are given. I have to find the average velocity of the 4 intervals. So it is 1 comma 1.5, 1 comma 1.1, 1 comma 1.01. It reaches to 1. So it will approach us to 1, right? So this is what you have. Now this is the same rule we will have, the slope rule. So m equal y2 minus y1 over x2 minus x1. So x1 here, the velocity, the s of t is given by here, this one. So s of t is this part. S of t is 2.4 into t power 2. So I just fix in the calculator, give the 1.5 and 1 over zero point 0.5, the answer will be 6. So you will get a answer for the first term. And similarly, if you calculate all the term, you will find the answer by using slope method. Now go to the derivative method. We will go to the derivative method is the same rule. First we will calculate the numerator part. So after calculating, just substitute h with the h cancel. The remaining part is this part. So I have, this is the average velocity. Here I have to substitute the h and t. What is h? H is nothing but the t is sorry, the t equal 1 and h is the difference between these two parts, 1.5 minus 1, which is zero point 0.5. Therefore the average velocity is this one if you substitute. Next, similarly, the t value is 1 and the h is minus subtraction 1.1 minus 1, which is 0.1. So you will get the average velocity. So if you compare this one, the result is going to be the same. There is no change in the result. There is no change in the result. Now the next one is asking the instant velocity. So at the point value is given. What is the point it is given here? So x value is approaches to 1. So if you see the limiting value, it will, as the 0 increases, it will reach to 4.84, 4.8. As the 0 increases, you will get 4.8. So therefore, when t equal 1, therefore it reaches to 4.8. Now, when you take the derivative method, you have to take the limit h approaches to 0. So if h approaches to 0 for this function, so this part is entirely 0. So 4.8 into t. So I just substitute t equal 1. So it is 4.8. So this is the two problems we have solved by using the slope method as well as the derivative method. Thank you.